Welcome to tutorial for page 46 problem. It's the one related to the use of different symbols in GD&T. So I will start a new part in millimeters. So I will say metric, standard millimeters. And I'm working also at in audio move right now. So I will create symmetric rectangular shape across the coordinate system indicator. So to activate the coordinate system indicator, because I'm now working in the move, so I have to do this anytime I log in. I will go to application options and I will go to the sketch, and I want to make sure that I have grid lines and coordinate system indicator, and if this is a little bit too big, make it smaller so you can say okay. And I will start my 2D sketch, and I will open here origin, and I will use XY plane. So once I am in the XY plane, I will make two lines that are construction lines. So one is going vertically up, and I will say escape, then escape again, and then I say line from the center to the right. So you see I have two lines, one is horizontal, one is vertical, and then I want to make sure when I start my rectangular shape, 2-point rectangle shape, that I want to turn off the option for construction lines. So then I would just make some shape which is not really 100% symmetric. So what I will do here, I will say symmetry, and then it's saying select first sketch element, select second sketch element, and in the middle. Now I say escape, and again reselect symmetric, and I go up, down, and the one in the middle. So now I constrained this rectangular shape, so it's shown like this. So here they're not really specifying immediately how big are these things. So I will assume, because they're saying here that nominal height of this part is 40. To me, it kind of look like that this might be 50, a little bit bigger than that height. You can measure and determine the right, or we can change it up later. So you see now when it's out of the screen, middle mouse click twice and you will get it. And I want to check in document settings and units, am I using the right size? So I'm using millimeters, that's good. And I want to say here, what kind of precision I'm using. So default tolerance, we will see here what we will have later. And then in terms of how big is the width, maybe I can put 80, and then later I will see if it's not 80, I can change it up. To me, it looks like it might be 50, 80, and we can change this later. So the overall height might be 40, and I will just try to make this first base up by 10, because I do not have the true dimensions of this. And then I will add fillets. So my fillets are going to be maybe, if I try with 5 and then see how it works, do I need a bigger one? 5, I think 5 is good. So I will put 5 in the corner. So here, shift middle mouse click, and there I have that. Then I will have one feature in the middle. So I'm selecting the mid plane, and there all I have is one circle. So that circle will be approximately this big, and let's make some round value. So maybe 40, because I already put it in the middle. That's why I was using symmetric. So I do not have to specify any other dimension. It's located in the center, so the location is fully defined, and this is defining the size. So I always have location and the size. And now I will extrude this by 30 to achieve overall 40. So you see the lower one was 10 and this is 30. And then I will drill some holes. So I have these four holes. So I will start making hole here. So I was using 5 for dimensions. So For the hole, I will make a linear hole, and I will switch to this kind of hole, and then I will just tweak dimensions and see how big they should be. So maybe I don't know, let's start here. 10. This one, I don't really see how deep this goes. I have overall 10, so we will see. And then or if I have 10, here I have 15. So let me just make it, and then I will see which dimension is. So face will be here. I think the hole is a little bit too big, so I will put references from one side. I will put 5, and then from the other side it will be 5. Let's see if I need to vary. Maybe it's a little bit bigger. 10. And for the first one, if I put 10, kind of better. It's just a little bit big. So what if I put outside 10 and inside maybe 8? That would probably be more like what I have, 7.5. So let's see how it looks. And I want to go to the front plane to see size-wise. I think it should be a little bit bigger. And I can easily change if I go to hole and I vary. So let me see if I put 10 and if I put 12 here. 12.5. Maybe a little bit smaller. 9. Or you can vary. I do not have. Later we can see in the problem what's the right nominal size of the holes label. NA, it's 8.5. Okay, so now I'm reading in the text. It's in the line 3, so they're saying it's 8.5 nominal size, and the top thing is 14 millimeters. So it's number 3. Hole A is 8.5. The top side of a hole must have a tapered lid in a 14 millimeters diameter with included angle of 90. Okay, that's the kind of hole. They have the title block tolerance applies to the countersink diameter. Okay, then 2 holes number B, they have, okay, so 15 millimeters. Okay, so the ones on the left, they would be 15. So since this is on the left, I will put this one as 15, and I will make one more hole here on this plane, and I will use all the same dimensions. I think I had 10 there, and then 10 from here. So here this was 15, and inside was 8.5. Okay, and then I have 2 holes on the right, and they're a little bit different. So in terms of it's a linear hole. I already selected the plane. This blue is plane selection. I'm selecting here above 10, and the one on the right will be 10. And then they're saying that the holes labeled A, the what's in the there should be 14. And then when I do another hole here, and again that will be 14, which is correct. Here I'm saying 10 from the bottom and 10 from the side, and that's basically what I have there. And then I will put another hole in the middle. So I'm saying hole, and this hole will be counterbore. This will be the face, and I will make this one concentric to the outer circle. So you see that's not picking it up correctly. So before I make this hole, it will be better if I would make axis inside of this circle. So I have this axis, and now when I try to make this kind of hole, and if I say concentric, and if I want to say concentric reference, I can pick my axis that I made, work axis, or or maybe I need to put a point. So I would do it then differently. I will go to the start to this sketch, and I want to make so here if I can put a point right there, because I need that point as my concentric reference. So now when I'm saying hole, I can pick that point, or from a sketch. Yeah, that would be. And let's read. So they say nominal height is 40 millimeters, and they have 6 to 6.4 millimeter square hole must go through both sides. That's another one. And the hole in the middle, they're saying that's 16.2 diameter. Or the hole is 16.2, and the counter bore is 17.7. And they're saying the hole in the center is 16.2. The hole can get 0.2 bigger but not smaller. A second 30 millimeters flat bottom coaxial hole must be machined. So this is what they're saying, that goes 30 millimeters. Well, the upper one will be 10 because the lower is 30. Okay, so if I put 30, I will have something that looks like the one we have. So in parametric modeling, we can always make a CAD model, and then later we can adjust it. And there's one more feature here. It's a hole from a side. So to create that kind of hole, I will pick a plane, and that's not XY plane. It might be this XZ plane, and I will say right click, new sketch on that plane, and what I will create here, I will make one line which will be this construction line. So I will go up, and then I will make one rectangular shape, and I can switch view to the wireframe. So now when I make this small rectangular shape, so when I go to sketch, rectangle, make sure you don't have construction. So all I have to do is make rectangular shape there, and I can use again symmetry. So symmetry, left, right, middle one. And then they're saying that that's a 6.4 square hole. So I'm using equal because this is 6.4. So I'm saying 6.4. And kind of looks in the middle. So I think this one should be a little bit deeper than 10, so I might switch it to 20, this hole. And then I'll go back here to make sure I fix this. So if I say equal, it still doesn't have possession. So the last hole I did, I'll put this one to 20. And then I'm going back into my sketch 4 to see this one a little bit too deep, maybe 15. So if I go to my previous hole and I say edit, oh, sketch is fine. I need to edit feature. I edit feature, and then I'll make it 15. I do not have information how deep it goes. I'm just making something that looks similar to that. So now I can make a reference dimension if I project this line, and I can say it's 15, and it will be my reference dimension. I cannot change it, but I need that information because here what I want to say that this will be 15 minus 6.4. So I put here minus, and I can put this in brackets, and I can make my equation there and say, okay, that divided by 2, whatever that leftover is. So you see now this would be, if I change 15 this will be still in the middle. So you see, in that way I programmed that. So I can easily put equations. And now when I have that, I can say I would like to extrude, I would like to cut, and I really want to cut to both ways like this, and I can say all. And basically it will remove, protrude this hole through the whole thing. So when I switch to the view, visual style, shaded with edges, that's what I will see. So if I check what I see from one side, that's basically what you see. And if I go from above, it pretty much looks like what I have there. And then later when I will do my drawing, I can determine what I actually want me to do. So I will save this. That's chapter 4 problem from the page 46. So I can call it problem. So also make sure you go to the H drive. So make sure you save it to your H drive, and we can save this like homework 3. Or we can call it flange or something. So now if I want to make the drawing from this, I will say, can you make me a new drawing and make sure it's metric, standard millimeters, create, and again, oh, it said part. So I will say file, save new, drawing, and I will change my sheet to B, because that's when I see my table better. And I'll go to ANSI large, edit definition, put my name, university. This is part 4. So I click here, put part 4. Title, I might call it some kind of flange or something. Creation date. Okay, finish. Yes, and then I will say here escape when something like that happens. So base view. Here, oh, I really just maybe need 2 views. Let's see how big it can be. Maybe it's too big. Maybe leave it as 1. And then for the second view, I would like to have a section view. Section view. And then here when I see green, I'll go left, right. So maybe make one view like this, and maybe make another view, section view, so I can show what's going on with these other holes, how they look like. And then put one view from a side. And that's about it. And then I can put one 3D view. So here, if I click, I move this view a little bit to the right, and I say, and I click on the home. You see, I can see default, and I can turn the shading on this one by turning on the shaded view. So basically, that's what I have right now. And now it's the time to add all these center marks for all the holes and all the radiuses. And then center lines. Anywhere I have cylinders in a side view, and that's pretty much here, the whole part. So I can extend it. And I can also use bisector. And that's about it. So now it's time for me to add these dimensions that they want me. So they say the nominal height of this part. So the nominal height, I can put it maybe here. There should be 40. So if you're not getting 40, that's a signal we need to switch document settings, and we have to pick here different units. So default standard ANSI millimeters. And then we should do this again. So dimension, that would be 40. Oh, that's not height, I'm sorry. Here, the height is there, 40. I mean, I do need that one. I'm not going to remove it. I need the other as well. So I can move this one, or I can move this section view a little bit outside so I have space for these. Okay, so the nominal height of the part is 40 millimeters. The tolerance on the height is 1 millimeter equally distributed, which means I will go there and I will say I'm having a symmetric, and they want me to put 1 millimeters. 40 millimeters, 1 millimeter up and down. That's like that. Provide instructions to the inspector that the height of the part must be verified by using a height gauge when the bottom of the part is resting on the surface plate. So I will let you do that part. I will put here some of the tolerances. So then 6 to 6.4 square hole must go through both sides of the part with an equally distributed side tolerance of 40. So they're saying 6 to 6.4, which is telling me that I need to go back to my part and find that hole from the side. That was my last extrusion. And most likely nominal would be, they're saying 6 to 6.4. So and it has side tolerance of 0.4. Most likely it's 6, and it can range from 6 to 4. And if I go back here to the view visual style wireframe, you see, because I used the equation, it's still centered in the middle. So I will say here, view visual style shaded with edges, and save this. So I changed 6.4 to 6. And now I'm going back here, and they're saying that this is a square. So I'm having this 6, and they're saying that will be deviation. Upper, it can go up to 6.4, so I'm adding 0.4, and lower it will be 0, because they said, they said equally distributed size tolerance of 0.4 must go through both sides of the part with equally distributed size tolerance of 0.4. Or I think when they say equally distributed, that might be 0.2, and then I have to move that to 6.2 because they're different limits. So I go back there and change my extrusion from 6 to 6.2. So I go to the sketch, edit sketch, and make it 6.2. Save, and then when I go back here, now because this is 6.2 and it's going plus minus, so you see it can be smaller, so it can go from 6 to 6.4. In that way, I can enable equally distributed tolerance, which is overall 0.2. 0.4, it's the whole. So the nominal size of two holes labeled A. Okay, so they're talking about these holes on the side. So this one, and if I add here 2 times, I'm saying, well, I think here, because they're so similar, I will put all of them. So you see these two are 8.5. There are 4 of them. I'll delete later if I don't need to show all of them separately, because there is a small difference in something related to the holes. You see, these are 8.5. The nominal size of two holes, 8.8. The top is tapered. So this one is 14. So 14. And then so 14 millimeters with included angle of 90. The tidal block tolerance applies to countersink diameter. Okay, that's something I will leave for you guys to do. So, and then these two will be 14, and I can put, because these are all the same, 8.5. I will just put here 4 times. Okay, and then these would be different. The ones on this side, they're 15. So I will just dimension them so we don't make mistakes. You know, what is 14, what is 15. You see, the ones on the left, they're 15. The ones on the right are 14. And then, so they're saying that the ones on the right, they're mentioning these ones, that they have tolerance symmetric. Oh, it's the deviation. So here it goes plus 0.2 and it goes minus 0.1. See on this one? And they're saying that the same one is for this hole, the one in the middle. So we will say deviation 0.2, and the other one goes 0.1. In A, they didn't mention what is there. They said tidal block tolerance. So whatever it's default for the drawing, we don't need to add it specifically. So the hole in the center of the part is 16 point. Let's see which one is it. 16 point. The one completely in the center. This one. 16.2. The hole can get 0.2 small bigger, but not smaller. We will again use deviation and we'll say it can just be 0.2 bigger, not smaller. A second hole, 30 millimeters. 30 millimeters must be machined a minimum depth of 17.7 millimeters. So let's see if we have correct one. I can put a little bit there. So I will say here deep by 17.7 millimeters. Oh, they have minimum and maximum depth. Okay. So they say 17.7 and maximum 8.3. So most likely that will be 18 millimeters, and we will have symmetric plus minus 3. Plus minus 0.3, and I will remove this one. because I want to say 30, go down by 18, and that 18 has and I want to check if it's 18 in my part, because now I got information how big is it. So I'll go to edit feature and make sure that the depth of this is 18. Okay, so now when I say save, go back here, I can check that here. And I want this one to be 18. And 18 will have that symmetric by 0.3. Let's see just where I can fit the number. I mean, I already put it up there, so I don't need it at two different spots. Okay, so here, here are some basics. And of course, save this by the same. You can save with the same. So let's check. They're saying the nominal height is 40. I have that information here. The tolerance on the height is 1 millimeter, so plus minus 1 millimeter. Provide instructions to the inspector that the height of the part must be verified using the height gauge when the bottom of the part is resting on the surface plate, which means I would need to add height of the part needs to be verified. Okay, and then and here where we have this square, we can actually add square in before this dimension. We can add the square because that will tell us that's the square of 6.20 plus minus that information. And for all these holes that are going through, we can always define their depth as through. So here, where we can say, we can put here that they're going through. THRU. THRU. Let's dimension each one of them. And when we want to say that this 40, it will have an origin from the one below. So basically, if we're measuring from a surface, we can right click here and say options, and we will check here, can we say second arrowhead inside? And in that way, we're saying it starts from this plane. So let's see, does it have any other option later? And if we double click here on the arrowhead, we can change that to a circle. So in that way, what you had on the page 41, you can see that if we want to say with dimension origin symbol, that we're starting from this plane and measuring up to there, that would be dimension origin symbol consists of a circle in place of an arrowhead on one end of the dimension line. The dimension origin symbol is used to denote that the dimension between two surfaces originates from a plane established from one surface to another. So you see anywhere where you click on the arrows, you can change style of that arrow. Okay, so now if we want to check 0.140, the tolerance, it's one up, one down, and we said that the height had to be verified for this bottom plane. Number two, we're saying square hole 6.20, and we're saying that it has equally distributed size tolerance of 0.4 millimeters. So I said plus minus 2, and then the nominal size of these holes A is 8.5, and that we have 40 millimeter diameter there, which is tapered by 90 degrees diameter, which, hold on, I should see that here in this view. So let me see if that change was propagated in both of them. So here, there should be this other kind with 90 degrees. And then this one also should have this other kind with 90 degrees, okay? And these other holes, this one is good, but then the hole too. So you see, I noticed in the side view that it wasn't properly tapered. So now, when I went there, since the drawing is associative, I can go here and I can see, now it's tapered, and I can really see angle there. And I mean, you can also dimension something related to the hole, these depths, and see some other information that we do not see over there. So maybe where's this square laying, what's going on there? And also, if you're missing any other, like how big is this one? We can put it here, and you can always move any of these extra dimensions, like there. So then the number 4, the hole labels B, which are these two, have size of 8.5, and they have an equally distributed tolerance of plus 0.2, and they go 0.1. The top surface around each hole must be cleaned to a 15 minimum diameter area. That's 15. And then the hole center in the center is 16, and that hole can be 0.2 bigger but not smaller. And the second one is 30. So that 30 flat bottom coaxial hole must be machined to minimum depth of 16 point. So here we have that 16.7 to 18.3. Well, we can probably say here limits, and we can say that it goes from 17.7 to 18.3 if we want to do it like that. If you want to change exactly precision like they said, you can always right click on any of these and set precision to exactly the level they said. So here I think all these tolerances, they're mentioning nothing has 3 digits. And even here 50, we only said 50, so you can switch precision on any specific one by exact value, that what you want to see. So you see if they didn't say, so you can change them manually. And then the 4 corners of the part must have radius of a minimum of 9 millimeters and a maximum of 9.6. So let's see what we put for fillets. 5, so it should be 9 millimeters. I'm changing that, and now I'm going back. The 4 corners of the part must have radius of minimum 9 and a maximum of 9.6. So now if I dimension that radius, I can go here, try this dimension, see where I have space for it, maybe here. And also I have something I need to say. So I can also use limits, and I say from 9 to 9 to 6. Just see how can I better fit them. So maybe you can always move. So you see if I move parent, the children will follow, and I can maybe make better arrangement for what I have in my drawing. So here looks like I have a little bit of space. So at the end, you can just try to align the best you can these dimensions so they look cleaner. And I think here it went, precision should be bigger because otherwise I won't see what's going on. And if something is too crowded, see if we can move it a little bit. Just to make sure nothing is overlapping or touching corners. And once you're done, check, do you have all dimensions? Maximum dimensions. Do we have location of these holes? I think we don't. We can put it here. And on the other view, we can put that location here. We have a depth right there, but maybe that will be more visible in this one where we can see what that hole really means. So I will put it here, but I can move this 40. Oops. Here. And once you're done, all you have to do is save and say here, export PDF. And thank you for watching. I hope this tutorial helps you complete application problem on the page 46 in the textbook.